Okay, let us see the sixth example, which was asked in CBSE 2016, 18, and then in 19. Okay, the question says, prove that the area of equilateral triangle described on one side of a square is equal to the half the area of equilateral triangle described on its diagonal. So there is a square. Okay, let's name this square as A, B, C, D, and equilateral triangle on the one side of a triangle. Let's draw an equilateral triangle on this side of the square, and let's name this point as E. And equilateral triangle on the diagonal. Let's draw equilateral triangle on the diagonal, and let's name this as F. Okay, I'll use some different color. This is equilateral triangle. Okay, so what we have to prove, so given, first write what is given. Given is ABCD is a square, CD is a square, and what else is given? Triangle BCE, which means this triangle. This triangle is equilateral, equilateral triangle, and also triangle AFC, this triangle, the red one. This triangle is also an equilateral triangle, is equilateral triangle. Okay, these three things are given. What we have to prove? We have to prove that the ratio of the area of the triangle BCE, that is this blue triangle, upon ratio of the area of this red triangle, triangle AFC, is equal to 1/2. Okay, so how to prove this? First thing first, let this side be x. Okay, so as this is a square, so this will also be x, and this side will be, by Pythagoras theorem, it will be x square plus x square root over, or 2 root 2x. Okay, so this side would be root 2x by Pythagoras theorem. And if this is x, then this is also x, this side is also x, because this triangle is, blue triangle is equilateral triangle, and also the red triangle is also a equilateral triangle, so this side will also be root 2x and root 2x. Okay, and one more thing, that triangle AFC is similar to triangle BCE. Why? Because they both are equilateral. All angles equal to 60 degree. This is also 60, this is also 60, and here this is also 60, and this is also 60. So by a similarity, the triangles are similar. Now, as the triangles are similar, so what we can say, the ratio of their areas, that is the ratio of area of the triangle BCE upon the ratio of triangle AFC is equal to square of their corresponding sides. So if one side is x and this side of a triangle AFC is root 2x, so whole square, so which will be equal to 1 by 2. Hence we have proved our final result. Then let's take up the 7th example. And in this example also, what we are given, again in this also we have to prove that area of an equilateral triangle described on a side of a right angled isosceles triangle. This is an right angled isosceles triangle is equal to half the area of equilateral triangle described on its hypotenuse. Again, this is equal to this. Again, same method is same. Let's name this ABC, and this is as D, and this is as E. So this is isosceles right angle triangle. So if this is x, then this is also x, and this triangle is equilateral triangle. Okay, so this is also x, this is also x, and by applying Pythagoras theorem in triangle ABC, what we will get, this side will be root 2x by Pythagoras theorem, and if this is root 2x, then this is also root 2x, and this is root 2x. And again, these two equilateral triangles are similar because all angles 90 degree. So this yellow triangle is equal to this red one, this red triangle. Okay, so let's write it. They are similar, therefore ratio of the triangle ABD upon ratio of triangle AEC is equal to square of their corresponding sides. Where is ABD? ABD is x, and AEC is root 2x whole square, which will be equal to 1 by 2. Okay, now taking up the 8th example, this is the last example on the areas of the similar triangle, and this question was asked in CBSE 2016. In this example, if D is a point on the side AB of a triangle ABC, let's take a point D, such that DB, let's take it as the, such that AD upon DB, this ratio, this is AD 3 is to 2. Okay, and E is a point on BC such that DE is parallel to AC here, and this is parallel to AC. Okay, then we have to find the ratio of area of triangle ABC upon the triangle DBE. Okay, so what is given to us? First thing is AD upon DB is equal to 3 by 2 and DE is parallel to AC. So we will always make sure that we use these two given facts. So let's continue. This is parallel, okay. Again the triangles will be similar. Why? Because the line DE is parallel to AC. DE is parallel to AC. So these corresponding angles will be equal. So by AAA similarity, triangle DEB is similar to triangle ACB. Okay, these two triangles are similar. So we have used this fact, parallel line fact we have used. Now this we haven't used. So again, when they are similar, then this implies that the ratio of their areas, that is ratio of triangle ACB upon ratio of the triangle DEB will be equal to the square of their corresponding sides. So which side? Obviously I'm going to take this side because we are given a relation between these two sides, so we'll take this side only. So it will be AB upon DB. Okay, so this is AB upon DB whole square. Now AB, what is AB? AB is AD plus BD. So what we have to do, if let it be X, okay, let AD be equal to no, it's actually, yeah, we are given AD upon DB we are given is equal to 3 by 2. So let's add 1 to the both side. So this side it will be AD plus DB upon DB is equal to 5 by 2, and again AD plus DB is equal to AB. AD plus DB is equal to AB, this whole length. So we have AB upon DB will be equal to 5 by 2. So from here we can write, instead of AB by DB we will write 5 by 2 whole square. Yeah, then which will be 25:4. This is the final answer.